Alright, I'm going to start off by factoring out 9 to the power of x from my left-hand side, because all my terms are 9 to the power of x. And from here, 1 plus 1 plus 1 is going to be 3, so I get 9 to the power of x times 3 is equal to 999. So now I can divide both sides by 3 so we can isolate x. So now I get 9 to the power of x is equal to 999 divided by 3, which is 333. So now we have a much simpler equation from what we started with. So now to solve this, what I'm going to do is rewrite 9 as 3 squared. So now I have 3 squared to the power of x is equal to 333. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. Meaning 3 to the power of 2 to the power of x is equal to 3 to the power of 2 times x, which is just 3 to the power of 2x. So now this is equal to 333. Now what I'm going to bring into this equation are logarithms. And it's always useful to use logarithms when solving exponential equations because they're very helpful. And one of the reasons they're helpful is because they come with an important property that states that log a to the power of b is equal to b times log a. Meaning log 3 to the power of 2x, I can just move this 2x to the front. So I get 2x times log 3 is equal to log 333. And now I'm going to divide both sides by log 3. So I get 2x is equal to log 333 over log 3. Now I'm going to rewrite log 333 as log of 3 times 111. And if I have something in this form, this is the same thing as log 3 plus log 111. Now this is the same thing as log 3 over log 3 plus log 111 over log 3 which is equal to 1 plus log 111 over log 3. Now log 111 is the same thing as log of 3 times 37. So now this is equal to log 3 plus log 37 over log 3, which now it turns into log 3 over log 3 plus log 37 over log 3. And this is equal to 2 plus log 37 over log 3. So now if I divide both sides by 2, these two cancel out, these two cancel out. So I get x is equal to 1 plus log base 3 of 37 over 2. And this is the same thing as 1 plus log 37 over 2 times log 3. So this is my solution to this equation. Alright, so in this video, I'm going to solve the problem 2 to the power of 22 minus 1. So, to solve this, what I'm first going to do is rewrite this as 2 to the power of 11 times 2, minus 1. Now, if I have something in the form a to the power of m times n, this is equal to a to the power of m to the power of n. So 2 to the power of 11 times 2 is equal to 2 to the power of 11 to the power of 2 minus 1. Now 1 is the same thing as 1 squared. So now I have 2 to the power of 11 to the power of 2 minus 1 squared. Now the reason I did that and rewrote 1 as 1 squared is because now I can use the property a squared minus b squared is equal to a plus b times a minus b. So just to clarify, a is 2 to the power of 11 and b is 1. So now I get 2 to the power of 11 plus 1 times 2 to the power of 11 minus 1. Now what is 2 to the power of 11? Well, 2 to the power of 9 is 512. 2 to the power of 10 is going to be double of 2 to the power of 9, which is double of 512, which is 1024. So 2 to the power of 11 is double of 1024, which is 2048. So now I get 2048 plus 1 times 2048 minus 1. Now 2048 plus 1 is 2049, and 2048 minus 1 is 2047. So I get 2049 times 2047. And now, a simpler way of multiplying this, rather than the usual method of this way takes way too long. So a much easier route is to rewrite this as 2000 plus 49 times 2000 plus 47. Now from here, I can simply distribute. So I have 2000 times 2000, which is 2000 squared, plus 2000 times 47, plus 49 times 2000, plus 49 times 47. Now 2000 squared is going to be 4 million, plus 47 times 2000 is 94,000, plus 49 times 2000 is 98,000, and finally 49 times 47 is 2,303. So now by adding all these up, I get 4,194,000, because 94,000 plus 98,000 is 194,000, and then I have to add in the 2,303, so now I get 303 at the end.